Hi class, so after grading today's quiz on geometric probability, I realized that we need some clarification on how to find the probability. So I rewrote the problem that we were given in our quiz today. So we have a circle, and it has a radius of 7, and then we have a circle inside the circle that has a radius of 3. I noticed a lot of y'all were trying to subtract the 7 and 3 and trying to find the radius of just this part right here. But we really want the area of the whole circle, and so we wouldn't subtract those two. And so the first step we would want to do is find the area of the larger circle. And to do that, we know the area of a circle is a equals pi r squared. And we know our radius of our larger circle is 7. And so we have area equals pi times 7 squared. And then we can go from there and put it into our calculator. So we have pi times 7 squared. And I'm just going to go ahead and round to 2 decimal places. So this gives us 153.93 inches squared. And then we have to find the area of the smaller circle. I'm just going to write it down here. And so the area of the smaller circle would be just the same, except for our radius is now 3. So we have our area equals pi times 3 squared. And so our area equals pi times 3 squared, which is 28.27 inches squared. So now we have the area of both our shapes. And then if we want to know the probability of the unshaded, we are looking for the area of that inside circle. And we already know the area of the inside circle, which is 28.27. So that's what we want. We want to land on the inside of that circle. So remember how to find it is that the probability equals the area of what you want over the larger area. So the area of what we want to land on the inside of the circle, and so that was the area of the smaller one. So the probability equals the area of the smaller over the larger area, which is the big circle, which is 153.93. I noticed a lot of y'all were trying to add these two numbers together and get the area of the whole circle plus the smaller circle. But when you're doing that, you're finding the area of the big circle and some, but we just want the area of the big circle. So you would just take the area of the larger one. And then we would put that into our calculator. We get 28.27 divided by 153.93. And we get 0.18 roughly. So the probability of landing in the unshaded region is 0.18 or 18%. Now, a lot of you made it this far and didn't know where to go after this, and you just kind of left it. And so I was counting heavily on this work and less on this work. So know that that's the next step that you would need to take. Also, some of y'all found the probability of the shaded region, and so if we wanted to find the probability of the shaded region, we would actually subtract the area of the larger one from the smaller, the larger minus the smaller, and that would give us this area, and that would be the area that we want. So depending on what you want, you will either subtract them, 153.93 minus 28.27, and that will give you the area of the shaded region. But in this case, since we were asking for the unshaded, we didn't have to subtract anything, and we just needed to divide it. So hopefully that y'all are working on the review, and then that y'all can work on some geometry problems, because I noticed a lot of struggling going on in there. And then also make sure that you are labeling your answers. And so when we're finding the area, we're actually squaring our label. So if we have centimeters, it's centimeters squared, inches, it's inches squared, and that kind of sorts of things. And then hopefully this video helps you so that way you have a better understanding of the geometry, and then hopefully on the test you'll do much better than the quiz. So